Welcome back to the Crooked Smile podcast brought to you by Macromedia Group. Today we have on Astrophysicist Dr. Georgie Taylor, Doctor of Space.
Space Doctor. No, really interesting listen. We learnt so much about, her academic journey and also what she's doing now, and just in general challenging the status quo, not taking everything as gospel and being willing to look at where that, data's from and analyze it like that. So,
Great episode. Make sure you listen through to the end, like and subscribe. Georgie, thank you so much for being here. We really appreciate your time.
Dr. Georgie Taylor, welcome.
Hey guys.
Welcome.
Thank you.
I guess to start this podcast episode with a pretty big, broad question, what is an astrophysicist?
Yeah, good question. So I was going to look up the Latin names for all of this. It's a funny one. So have you guys heard of astrology?
Yes. Star science?
Yeah. So ology is like the study of something, but astrology kind of got in there first, with astro just sort of being, I don't actually know the definition of astro, but I'm going to assume like outer space. So they got in there with the study of outer space. So astronomy is like the measurement of outer space, and then astrophysicist is like the physics of outer space. But I sort of use astronomer or astrophysicist interchangeably. My degree is actually in both astronomy and astrophysics. So a little bit of the measurement and observation, a little bit of the underlying physical laws. But if you move away from the actual definitions and you're talking about what you're doing day to day, an astrophysicist is observing what's going on in outer space, usually quite far away, and trying to make sense of what they're seeing. So no experiments or anything. It's not like a regular physicist where when you're in a lab and you can repeat experiments and everything. You can really only look as an astrophysicist and try and interpret what you see.
So on the hierarchy of all those professions, you're like the big dogs.
That is one way to classify it. I don't know. I don't know if anyone else would classify it that way.
The big dogs in the astro world.
Yeah. So does that mean you believe in things like the Big Bang Theory? That's just the stereotypical stuff? Star signs?
Ooh, combined two interesting things there. So let's start with the first one. So Big Bang Theory. Big Bang Theory is actually related a little bit to what I worked on for a lot of my PhD. It's basically the origin theory of the universe. So the universe as we know it, from our best estimates, about 13.8 billion years old. And because the speed of light is finite, when we're looking at things that are really far away with telescopes in outer space, you're looking back in time. So that's how we can kind of understand the age of the universe. We can also understand the history of it. It's kind of like if you were watching a movie from an earlier part of Earth, but you're looking at observations from an earlier time in the universe. You can't see all the way back to the Big Bang though, for a couple of reasons. First of all, it's really far away, and our telescopes are a little bit limited by what we can physically achieve here on Earth, size of the mirrors and so on and so forth. And secondly, the universe gets very opaque at a very early point, so everything gets very dense. It was very hot. You basically can't see through it the way that you can traditionally see through space at the moment. So the Big Bang Theory, this idea that everything in the universe started really small and expanded out, the expansion we can see, we know that very robustly. We've known it for about 100 years now. But the actual Big Bang Theory itself is still a theory because we've just had to extrapolate from the observations we have at the moment from what sort of makes sense intuitively with the way we understand physical laws on Earth and expand them to the Big Bang. So it is still a theory. It is the theory that makes the most sense at the moment, but it is still very possible that it could be disproven and something else could come through. There's this idea called Occam's razor in science, which is the simplest explanation is usually the truest one. And at the moment, that's kind of how the Big Bang has sort of solidified its place. It lines up very well with a lot of observations, and it's quite a simple explanation to help us understand what we see at the moment.
See, I wonder, because going back a few years, I know Galileo was very outspoken at his time when he was talking about the universe and that the Earth doesn't revolve. No, everything doesn't revolve around the Earth. The Earth revolves around the sun. So, is it possible that you could be the Galileo Galilei of our time?
With the Big Bang
do you
Theory?
think you would be able to break through with something new to the Big Bang Theory? Or do you think if anyone came up with something alternative that they would just not get enough airtime to,
No, yes, you're absolutely right. So this is the fun thing about science, right? It's not as precise as you might expect. You are still working with limited observations. You're working with limited knowledge. So you're just having to interpret things the best you can. And the best thing about science is it's a public body of knowledge. So everybody can read it. Everyone can try and disprove it. And that's what scientists love to do, right? And that's what we need them to do in order to have this robust body of knowledge that we can collectively build on. You don't want to just have something, take it as gospel, and then move on to the next thing. You want to actually prove that something is right or wrong. I can give you a really good example of that, which basically started my entire field. So are you two familiar? Okay, maybe I should take a step back. How much do you know about space? How much do you know about the universe?
I'm a Virgo.
You're a Virgo? Okay, cool.
All I know is that I'm really scared about space. Like, I know as an astrophysicist, you probably have to embrace that, like just the emptiness and the darkness and just the vacuum that it is, but that scares the crap out of me.
I've seen Interstellar.
Okay, cool.
So
I got a pretty good understanding from Interstellar.
Very poor level of understanding.
Well, maybe if you'll humour me, maybe I'll take a step back and I'll just talk very quickly through some of these concepts that I'm going to explain.
Speak to us as if you're speaking to 5-year-olds.
Okay.
No, I'm kidding.
Okay, so we have our solar system, right? We've got the sun, our 8 or 9, depending on who you ask, planets, little group of asteroids and things that float around in here. That's our solar system. We're in sort of a far-off arm of the Milky Way. You've probably seen artist renditions of the Milky Way, which is our galaxy. Mm-hmm. And there are like billions of galaxies. They're all pretty far away, but they sort of make up the universe. The universe is structured in what we call a homogeneous and isotropic way, which means no matter which direction you look, it's all on a very large scale, pretty uniform. It's all kind of the same. And there's no central point. So that's sort of this interesting thing about the universe is you can look in any direction, and if you look far enough, it's all pretty much the same stuff that it's made up of. It's like if you just have a bowl of cereal and mix it up, essentially. That is the universe. But it's also expanding out, right? Like I said, the Big Bang, you start small, the universe expands out. But what we sort of expected for most of the 1900s is that expansion would eventually start to slow down again. You have this big explosion or whatever it is at the Big Bang. It sends everything flowing far away, but then gravity would eventually start to overtake and pull everything back in. It's like you throw a ball up in the air, eventually you expect it to come back down, right? But what happened in about 1997, 1998 is there are 2 teams of supernova scientists. So I work on supernova as well. There are these exploding stars that explode really brightly. So they outshine entire galaxies. They don't go off too often, about 1 every 100 years or so in a galaxy, the Milky Way size. But because they're so bright, you can see them really far away. So we can kind of use them as traces for distances to other galaxies. So they were taking these explosions, looking at them and trying to figure out how far away these different points of the universe were. But you remember what I said about light moving at a finite speed, right? So they're also looking back in time when they do this. So they could trace how fast the universe was moving at different points in time. And the really interesting thing that they found in the 90s, which no one really believed for about 15 years, was that the universe was actually not slowing down in its expansion. It was still speeding up. So 13.8 billion years after the initial explosion, the universe is blowing apart faster and faster, which is absolutely bonkers. And like I said, no one believed it for a while. There were some physical theories that made sense with it. Einstein actually predicted this back in the 40s, and then he threw it out because he was like, no, that's nuts. Let's not do that. But eventually the team won the Nobel, or both teams won the Nobel Prize for it in 2011 because they discovered what was called dark energy, which is this mysterious force. So here's a little hack for you. If you ever hear anything described as dark in the astrophysics or astronomy world, it's just because they don't know what it is. Dark matter is matter. We don't really know what it is. Dark energy is energy. We don't really know what it is.
It doesn't matter.
Yeah, exactly. So dark energy is blowing things apart. And that's a really good example of, that they would be your modern Galileo Galilei. They were treated a little better, they weren't locked up and being, punished for being heretics. But it was a long journey for the scientific community to everyone go back through, make sure that they believed what they saw. They didn't even believe what they saw the first time that they were looking through these observations, So those are the really cool discoveries that move science forward. Is when you discover something that's the opposite of what you're expecting to see, and you don't change your observations to fit your theory. You change your theory to fit your observations, and the power of observation that we're getting now is unprecedented. We've never been able to observe the universe the way that we can at the moment. So, yeah, I do expect that a lot of the theories that are out there about the universe are going to be adjusted or be improved upon. At the end of the day, there's still people making up these theories, right? Trying to explain what they see. So there's always room for our understanding about it to change.
So is space never ending then, or it has?
It does actually have an edge.
So what's after
Crazy.
the edge?
What's after the edge? I do not know.
Getting really deep here.
Yeah. You've taken all of the interesting stuff in the middle of space, which is everything that has ever existed, and you'd be like, I don't care about that. I want to know what's behind it.
The constant pursuit of more.
It's one of those strange things where it's like, for me, I don't think about it that much because we're never going to see that far. Like, I promise you, we're never going to see that far, and we're never going to go that far. So it just doesn't matter,
Yeah.
It's like those like parallel universe questions and stuff. It's kind of interesting to think about if you're bored or you have a lot of free time. If you find yourself in that situation.
Okay, well, just touching back on something you said before, you were talking about how it was really hard to see through things with a lot of heat when around the Big Bang Theory. Does that relate to different dimensions, and is there multiple dimensions, or is that
an interstellar theory?
Yeah, I've did my homework and I watched Interstellar before this, and
Really
Interstellar
not
has
good.
like the multiple dimensions in space and that sort of thing. Is that all real, or that's just
Yeah. So let me ask you a question. How many dimensions do you think we have right now?
right now?
Yeah. Like in this room?
3 or 4.
4. Yeah.
4.
So we've got 4. So we have, your normal Cartesian 3 directions, this way, and I don't know, that way. And then you have time, right? And yeah, there could be more, but I'm not an expert in dimensions.
Sorry.
No, you're fine. I don't really know about that, but that's probably not why it was hard to see through these early particles. Essentially, they're really hot. So they're vibrating really, really quickly, and they're moving around actually so fast that they just sort of form this opaque soup, so you can't see through the particles because of the way that the electrons and the protons are interacting with each other when they are so hot. And everything that's in the universe right now was in that small area as well. So very hot and very thick. It'd be like, trying to think of an analogy where you couldn't see through. If you had a really crowded, room, you couldn't see through to the edge of it, especially if people are moving around really fast, and there's going to be no way that you can see through to the other side of the room and see what's happening over there.
I'm fascinated by all this, and I shouldn't say it's new to me because I probably should have tried to, understand it better, but it is still very, I don't know. I think the way you're explaining it's very easy. I know that before, in preparation for this, we watched a video that you did at ANU it said ages 7 to 13, and we were watching it, we were like, really? Which 7 to 13-year-olds?
That's funny. That's the video that I also watched in preparation for this.
Oh, really? Just a quick
just remind myself, yeah.
Well, I guess we should probably ask more about you and your journey and your interest, I guess. Was it as a 7 to 13-year-old that you started becoming interested in this area, or was it doing physics at school and then someone's like,
So this is where you probably should have got a better astrophysicist on, because I feel like I'm not going to be a good representation of the field. I didn't really care about astrophysics, maybe my whole life, including now, which is quite bad.
Damn.
Yeah. So I I always did well in like science and math at school, and it's because I enjoyed solving problems. I enjoyed doing the sums, getting the right answer, having that satisfaction. We never really did much astronomy or much to do with space at my high school. But I also didn't really find anything that I really felt called to go and do. But my parents did think that I needed to go to university. They were very clear on that. So I was faced with this decision where I just wanted to kind of enjoy my life. I wanted to spend a lot of time outdoors, maybe work on a farm or something. And they were like, no. You're good at math and science. You need to figure out what you're going to do with that. You need to go and get an education. So I was just flipping through a university prospectus one day, and I saw that they had an astronomy major at a university in Auckland in New Zealand. And there was also a table of data in there about careers with the highest like happiness level or career satisfaction. And astronomers were ranked number 1. Now, I do need to go back and look at that data because I have some questions about it now that I'm...
Damn, what was down the bottom?
I don't remember, and maybe I should have...
Finance or economics or something?
You know, I have... In my journeys as a scientist, I've learned to really inspect your data and really question things and where they've come from. And if I'd known that then, I might have ended up on a different path. And that's not to say that I didn't enjoy what I did and I didn't think it was valuable, but I didn't go into it because I loved space or I had this burning desire to figure out the universe. Because the thing about the universe is it's everything that's not here on Earth. So here on Earth, you have a lot of life-based everything, but everything else is in outer space, right? Which means you can't study all of it. You end up studying this really niche little thing. So the objects that I studied, the field that I studied, is one tiny, tiny little piece of the puzzle that makes up this entire world. It's very, very niche. So it's not even the whole thing.
Was there also a matter of like, what can I actually change? Like, what tangible effect can I have if I'm studying? Obviously, if you like
the Galileo arc.
Yeah, if you could do that, but like obviously with the work you're doing now, that's when you say that studying astrophysics is everything outside of here. Now you're doing something that's very important. Is there a bit of that, or is there a bit of existentialist dread that you feel when you're like, wow, I'm studying space, and like, what is it actually gonna?
I didn't really stop and think about it. I sort of felt if I worked hard enough, then I would prove myself and get to this point where I could be a professor of astrophysics and I could work on these cool things that I'd been working on all the time. And what I learned is that at that point, when you get into your PhD, that's when you really start to focus, and that's when you really start to work on these really difficult niche fields where you might write a research paper and 10 people read it, even though it takes a year of your life. And then the next year, someone might prove you wrong. So, for example, my first PhD paper that I wrote, I spent a year working on it. And then 2 weeks after I published it, someone who had in parallel been working on a different model that was doing the same thing published their version. And then we suddenly had 2 competing versions for a team of about 10 people.
Who won?
We actually ended up collaborating, which was the best possible thing that we could have done. Because it meant that both of the models became strengthened because we could look at each other's, we could find out where some of the bugs were. At that stage, we didn't have ChatGPT or any AI tools to go through our code and help us find where the human errors were. We sort of had to do it all by hand. So,
wow, that sounds like so long ago. What a crazy world.
I know. And then COVID happened, and I did most of my PhD from not the office, so not collaborating with people. You become more and more isolated, and especially in Australia, the teams I was working with mainly, I was part of a team called the Dark Energy Survey, who were mainly, it's pretty cool. They were,
it's like a band.
Yeah, right. They were mainly based in the States and a few of them in Europe. So it just became more and more like you feel like you're working really hard at something. And if you ever got that payoff for a really big discovery, then it might be satisfying enough to be worth it. But during those 4 years that I was doing my PhD, I sort of came to realize that the things that I really valued, which was connecting with people, working collaboratively on problems, maybe not having such a deep knowledge of one particular thing, but understanding how systems are connected and how small things in one area can influence things in another area and also benefit the lives of people who I know and care about. I realized that those were the things that were really important to me. And I think the way that traditionally academia is set up, which people are fighting to change, but it doesn't really foster those things. There's still a little bit of that, lonely genius mentality in academia. It's a bit of an introvert sport at the moment. And it wasn't a good match fit. So it was a hard decision to, turn down jobs in astrophysics after I graduated and decide to pivot into something completely different. But I think I still learned a lot, and I probably could have done astrophysics for the rest of my life and done an all right job, but just not been as satisfied as I am now in something a bit different.
So for the audience, now you're in mining and renewable energy?
Yeah. So now, basically, I had this mission when I left astrophysics that I wanted to have a climate job. It sort of felt like the most important thing to be working on at the moment, and it's also something that I felt there are a lot of pathways into. There's a lot of ways that you can contribute to that mission. So that was what I was looking for, and I also knew that moving to Perth, mining is a really good opportunity here. There are a lot of mining jobs. And I happened to just stumble upon a really good fit that combined the two of those. You have the resources of mining, the stability of mining, but the good fit in terms of, working towards decarbonizing. So now I'm a part of a boutique advisory group that manages the Electric Mine Consortium. So we work on helping miners and mining services and supply companies to decarbonize the industry, mainly through putting renewable power in and getting rid of their diesel trucks or replacing them with electric trucks, which have far fewer carbon emissions and also have far better health outcomes for people working in mining. So it really ticks those boxes of actually making a tangible difference compared to just sitting there and staring at the sky all day and being like, oh, what's that?
I was going to ask, first of all, would you like to quickly speak to your PhD? I know you've probably kind of covered it, but supernova cosmology, that was
mapping the expansion of the universe.
Yeah, yep. So like I said, my PhD actually follows on pretty strongly from that story I told you earlier about using the supernova to discover that the universe was in fact expanding at an accelerating rate. So when they first did that with about 50 supernovae, they were modeling it by hand. I was working to improve some of the tools that were developed in about the mid-2000s to help model it using technology. So for the Dark Energy Survey's 2023 papers, so our 5-year analysis, we had about 1,500 supernovae, and we wanted to model them with like extremely good precision, which we ended up doing. There were a whole lot of people working on this. It wasn't just me, and a whole lot of ways that we worked really hard to improve our analysis methods to reduce the errors on the measurements that we were making, and we actually ended up halving them from the previous analysis that was done in 2018, which was really exciting. So we went from a 6% error on our measurement of strap in the dark energy equation of state parameter, which will means nothing to most people, to a 3% error. So now we know slightly better what that number is. If you'd like to know, it's around -1, which is what Einstein predicted in the 40s with absolutely no data. So yeah, hard work for some people think it's a big payoff. I personally think in the grand scheme of things, kind of small payoff, but people worked really hard on it and they did do a really good job. And that's sort of almost a frustrating other side of the coin with astrophysics is you have very, very clever people and a lot of money going into trying to understand these things that ultimately are cool, but don't matter for life on Earth at the moment.
Well, that's what I was going to ask, because now you're outside of the community and you can look in, and you don't need to shade them if you don't want to, but looking in at the community, is it a lot of people just trying to
community
big ego to try and get good grants to do research, or is it very standoffish or?
There is definitely an element of the big ego and people faking it.
Really?
Yeah, absolutely. But I think you get that probably in every industry. I'll also say on the flip side of the coin, some of the best people I've ever met are astrophysicists and still work in astrophysics. And they are very, very good at what they do. And I don't want to, undervalue their work at all, because they actually are working very hard to connect these dots more broadly. But yeah, no, there's definitely a huge element of toxicity in it, particularly the more senior you get, the safer you get in your position. So once you get tenure as an academic, you can't really get fired, even if you're pulling some nonsense. So that also becomes a good reason for trying to move out of it and into the business world, I think, where you have a little bit more protection in terms of HR or legal recourse and things like that. I can't say too much, but
Call them out right now live on the podcast.
Yeah, it's a legal gray area, but no, it definitely was a learning curve as well. Trying to work through some of the community issues that we experienced as a community when COVID hit, but also we had a few culture things going on at my institute, and we're a very small institute. Where I worked, we only had about 100 or so people working on the whole of the universe up there. But it sort of taught me that the human side of things isn't really valued that well in academia. Even something as simple as communication, so telling the story of your work, trying to promote it, is sort of seen as unimportant or secondary to the work itself, which I think is a little bit silly, because if you can't tell people what you've done in a clear way and they don't know, then you're the only one that knows, and you're sort of doing a disservice to all of the resources that went into making those discoveries. So trying to fight really hard for, getting the recognition of the people that were working there and saying, look, everyone's going through a bit of a hard time, or everyone just needs a little bit more human support. So we're going to need to take a little bit of resources away from the science for a bit and look after the people that are doing this work.
Yeah.
I had one question going back to astrophysics.
Yeah.
And it's a bit out there, but I hope you can give a good answer.
Okay.
Literally out there.
Are aliens out there? Are they real?
Okay.
Oh, the soundboard's back. I almost forgot
love
you were
it.
there, Robbie.
So I can't definitively answer that question. In full disclosure, I have not been up to date with the latest alien discourse. I know sometime in the last year there was a lot of talk about
Whistleblowers in the US.
whistleblowers in the US. Actually,
Campbell's across it.
Oh, you're okay, cool.
I'm
So
a
you
conspiracy theory
you
nerd.
can
Yeah,
educate me.
yeah.
Actually, this morning, because I thought maybe they're going to ask about aliens, so I Googled aliens, and all
Question
I could
mark?
and it just came up with the Sigourney Weaver film. So I got distracted down a
Classic.
rabbit hole. A classic film,
Classic,
right?
yeah.
Look, space is really, really big, and it's really far away. So our closest solar system, the closest star to us that could potentially have planets around it, is 4.6 light years away, which means if you're traveling at the speed of light, which we cannot because we are not light, it would take you 4.6 years to get there. It would take us much, much longer. Light moves really, really fast. So if aliens are out there, and they have in fact been coming to just the United States, the most interesting place for them to visit, obviously. Yeah, they would have had to come from very far away, and they would have had to come very, very fast. The interesting things about is when something is traveling that fast, it does emit light. So you probably would see it, especially with the amount of scanning that the sky that is happening in the sky, all the time. But I'm not ruling it out. What do you know about aliens?
Oh, I don't know a lot personally, but I've seen and
Yes, you
read
do.
that the latest theories are that there's a lot of stuff underwater that's unexplained. So UAPs, flying saucers, on scanners and radars, and pilots seeing them. And this is what the whistleblowers were, with pilots seeing these unanimous flying objects going at speeds defying physics.
Unidentified flying objects.
Yep. And then they'd go underwater and they'd maintain crazy speeds and it'd defy physics.
Yeah. So this is an interesting thing about physics, is it doesn't just apply to humans though, right? It applies to the entire universe. So it'd be weird, do you not think, if there were aliens? And I'm not saying there aren't, and if they're out there, sorry.
Allegedly. This is not my beliefs. This is just what's going on.
We have an unidentified segment of our podcast demographic that we're trying to explain. That genuinely, it's Yeah.
Again, if you go
Alien
Occam's razor,
listeners.
alien listeners, if you go Occam's razor, right, the simplest possible explanation, it could be aliens, or it could be some guy in a lab that came up with some cool new tech, and he's like,
Yeah.
probably should take this out to the ocean where no one can see me try and test it and like cosplay a dolphin or whatever it is that he's doing out there.
Cosplaying dolphins.
Yeah.
Okay,
But
interesting.
it could happen. And this is the thing, right? The way that life evolves, it just needs a certain set of conditions, and there are billions of planets out there, and some of them are probably going to share the set of conditions that we've experienced here on Earth. So there are almost certainly other life forms out in the universe, but whether they would bother to come over and be like, not even say hi, just sneakily be like, oh yeah, this is going to be our testing ground. That's a bit that I think I'm still skeptical about.
Same.
They've heard about the USA. The mass consumerism is spread across the galaxy, and they want to come back and see what's going on in the US.
So speaking
wanna
of
see.
conspiracy theories, is the moon landing real or fake?
So the moon, it's always in Perth. Someone asked some stupid question about the moon. That wasn't a stupid question, sorry.
sorry.
Wow, yeah. It was.
I'm just trying to take the audience's point of view and what they'd want to know.
My first,
From astrophysicist, I don't think that's...
so my first trip to Perth, someone asked me if the moon was a hologram, which I thought was like an interesting way to not understand the moon or holograms. Like it just. So that was that was like a war flashback when you asked. But no, so my understanding, moon landing, probably legit. Australia's Parkes telescope, which is this massive dish, there's a movie about it where they play cricket up in this dish of this radio telescope, actually helped to beam down some of the first images of the moon landing, because obviously the Earth is spinning. So it's not always going to have America facing the moon to look at their dudes up there and be like, hey, what's up? So Australia helped out a lot with that. So I think it's actually almost like treason for you guys to question it. And I would be careful.
That's crazy. That's our claim to fame.
A serious answer to your question, though, is so allegedly they put a little like box up there that you can scan a laser up. Probably not you or I, but if you had like a big powerful laser and hit it, and it will bounce back so that you can get really accurate measurements of the distance to the moon. So I believe that test is still able to be run today, which sort of indicates that, someone did go and slap something up
that's
there.
what I
Moon
needed.
landing real.
That's,
There we go, confirmed.
that's the only evidence I needed to disprove you, and I just didn't know anything about the actual...
Was this a long-held belief?
I don't believe. I was just
No,
asking because there's a lot of controversies around
He
it.
doesn't believe it now.
Hey, I go with the general public's opinion. I'm what
No,
you call a sheep.
no, it's very good to question things. This is
Yeah,
this
this
is
is what we're
good.
talking
Yeah,
about.
don't believe anything they tell you.
I had the pleasure of interning at Slate Advisory State of Play. I don't know if I'm supposed to drop the name, but maybe I'm not.
It's your podcast.
Electric Markets
You
on
do what you
I don't
want.
know.
We can
Over
bleep
the
it out if
summer.
we need to.
I think I'm just skeptical of how we're going to progress because obviously super ambitious goals set by the Paris Accords or the Paris Climate Agreement. I know there's companies out there that are super engaged, or at least give off the impression that they're super engaged in this, and there's other companies that are, I guess, doubling down on oil and gas and fossil fuels. So how do you see us placed, especially in Perth, where we're the hub of all this mining, oil and gas? Do you think we are going to be able to achieve those goals by 2030, 2040, 2050? Or I don't know, from the time you've been at Slate and State of Play and the stuff that you've seen with the EMC and the buy-in that you've seen from these companies, like what's your perspective on how we're going to the progress we're making, I guess? I don't know. That was a very poorly worded
No, it's just a
question,
long
but
question.
long-winded question. Yeah,
That's
yeah.
all right. I've missed these long-winded questions. No, that it's a good question, and I think it's probably one of the most important questions to ask, because there is a lot of noise out there. You can't really get away anymore with not speaking about the climate, not speaking about your ESG strategies, but specifically about your climate impact, because your investors are starting to sit up and take notice as corporations. But a lot of the talk that is out there is, as you said, Gianni, it's just noise. It's just people saying things. And what I've learned throughout my life is people will just say things and they might not do it and it might not be right. But if someone believes it for a year or two, it's enough to get them off the hook and get them to their next decision. So I think it's going to take a lot for us to get to 2030 at the moment. At the trajectory we're currently on, I would say no, I don't currently believe that we are doing enough. Not every single company, not every single person is not doing enough, but across the board, collectively, absolutely not. I think we need really strong leadership in that area, both from individual corporations who have the gumption to step up and take a risk to gain some competitive advantage in a green commodity space or in a green provider space, because a lot of the models are suggesting that there is going to be an advantage, but also what we need to support that is a lot more teeth in policy. So we kind of need the government to stop taking quite so much money from oil and gas companies and to start understanding that the people who vote for them are going to have their lives seriously impacted by this stuff. Same thing, so people who vote for them, probably I always encourage people, don't worry so much about getting a compostable takeaway cup or anything. Worry a little bit more about spending time emailing or calling or going down to your local MP's office and visiting them and saying, hey, I'm concerned about this. What are you doing? It doesn't even have to be about climate, but just engage with your local politics in general, because I think we're at the stage now where the problem feels so huge. We all acknowledge that there's a problem now. It's sort of undeniable. But it feels so huge that we're not really sure what we can do about it, and we've become a little bit dissociated from it. But within small systems, you can make huge change. So even things like local cooling, local emissions, they actually do make a huge difference to people's lives, people that you know in your community, as if not the world more broadly. So trying to think smaller, think what can you do on a local level to help things, while also holding your leaders, whether those are companies that are making millions, if not billions of dollars off of the resources that are coming out of Australia, which Australia is very fortunate to have, but will not have forever because those resources are readily being depleted, as well as, the governments and the people who are meant to be leading the country and doing things on behalf of all of the people who live here. I would say hold them accountable, because they are actually accountable at the end of the day to the communities, to their stakeholders, and everyone sort of needs to lean in a little bit, and then we'll get there. But you sort of, we're at the stage we can't get away with people not leaning in anymore. But it doesn't have to be a huge effort. You can once a month spend half an hour on it, and that's probably enough if we all did it.
It's interesting that you find that, and I think that's a really good way. And the companies that are really leading the charge are doing that, but that finding that competitive advantage in industries that may not exist yet. I guess it's just tricky if there's not a market or something, like say for nickel or something, they don't have the green premiums in yet, and they're battling supply in Indonesia and whatever. But yeah, I don't know, that's a way. And obviously as consultants and as an advisory, you have to kind of consult on strategy. And so I don't know, that's something that really cool that I took away, that it's not just like, okay, you have to make a massive sacrifice, cut all this funding away from your fossil fuels and, put it into something that's not going to provide you any good, just so that you look good on an ESG standpoint. It's, putting yourself in a position. And I know there's companies that are doing it. I know there's companies that are saying they're doing it. I don't know. That's an interesting battle. I think there's a lot of smart people that are doing lots of work on that. And I don't know. I'm thinking about the government's stance and this nuclear discourse that's going on, and that we should have done it ages ago, and that it's too late and stuff like that. But I feel like nuclear was a massive missed opportunity. Will continue to be a massive missed opportunity if we still don't embrace it. I don't know. How do you feel about? I know this is getting.
How do I feel about nuclear energy?
How do you feel about nuclear energy? Yeah.
Jeez.
I know.
Hard-hitting questions.
There's I know it's because I was talking to someone the other day that was saying the most optimal mix would be nuclear with oil and gas, and that would, if we had done that ages ago, that would have. This is probably just more out of my interest, but yeah. What do you
passion questions?
Yeah,
No, do it. Okay, so first of all, just like quick disclaimer, I don't speak on behalf of like the advisory company or any of the research that we've done. These are just all my own views. The second, everyone's got an opinion, right?
Yeah,
like
yeah,
everyone's out here saying something.
Like the moon landings fake.
Yeah.
Crazy stuff.
Crazy
like that.
people like that.
But I mean, this is the fun thing about the world and the society we live in is there's no one right answer. There's no one objective truth for anything, even physical laws, right? They're all just people thinking things and coming to agreement or disagreeing on things. Look, I don't know what the best nuclear strategy is. I honestly don't know that much about nuclear energy as it is. The most I know about nuclear energy is, and sorry to circle back to space, but the work that I did was on thermonuclear explosion. So when I think about nuclear,
It's scary.
I think about stars blowing up with like 14 octillion tons of like TNT. Like it's like big explosions. But I mean, get a nuclear expert on and ask them. I would encourage you to do that.
Yeah.
Unfortunately, I don't really know. I grew up in New Zealand where we don't have a lot of big empty space to put reactors, and we sort of have this green identity where we have a lot of connection to the earth. It's sort of a little bit more built into the dual culture that's there. So it does give me a lot of pause. I think just because of that background, like I wouldn't really like it in my backyard, but I think that's because my backyard is a little bit different to the Australian backyard. So I wouldn't rule it in or out at the moment.
I think a lot of people feel the same, and I think obviously I wouldn't want it in my backyard. So it's just like it's a really tricky thing. I guess people have to make sacrifices to.
Yeah, a lot of big holes in the desert
know.
though out there that you could go and shove something in, see what happens. No
I
one's
guess
doing anything with
a
them.
lot of empty space.
Yeah.
Yeah.
There is one other thing that I wanted to touch on really quickly
Yes.
because I feel like we nearly got there and then we kept steering away from it into actual science. So you were going to mention, I think, zodiac or star signs.
Oh, we've never got
I
to
feel like this
star
is a really
signs.
important
Yes,
question because
yes,
these
yes,
things
yes,
do
yes.
get confused a
As
lot.
a star doctor,
Are
this is
star
important.
signs real?
Are star signs real? So at the moment, the way the zodiac works is meant to be whatever the constellation or zodiac the sun is in when you're born, right?
Is that what it is? Oh, okay, yeah. Okay.
Yeah. So there are some physical correlations, like astronomical correlations with zodiacs. So there are, in fact, the 12 constellations that rotate through the elliptical that are meant to represent, the star signs where they are. But those were set out a long time ago, like I want to say over 2,000 years ago. And to give you a little bit of a movie analogy, because you all seem like you like movies, in Inception, the spinning top.
Yes.
I haven't seen Inception.
You've seen the object as spinning top, right?
Yeah.
You know how
It's
sort
like
of
a big blade.
Yes, no, I know what a spinning top is.
Okay, we've
I know what it. Let it rip. I know what a spinning top
exactly.
is. Yes.
So when they start to slow down, they start to wobble a little bit. You can see the top of them. It's called precession. So the Earth actually does that too. We're spinning around, but we're also wobbling on our axis. So the star signs that were in the zodiacs at the certain times of the calendar year, 2,000 years ago, are no longer actually there. So everyone's about a star sign off. So, for example, I was born in November. So traditionally, if you go off the calendar, I'm a Scorpio. But if you actually look at where the sun was when I was born, I'm a Libra. So, I know.
Oh no.
Oh no, I've got an identity crisis. I've got a star sign identity crisis.
And I don't know how that affects horoscopes or anything. Maybe they've adjusted them for that. Or maybe everyone's been out here getting the wrong predictions.
And that's why they're all pretty much the same.
Maybe that is the source of the issues in the world.
I was a Leo.
You were sure?
Outgoing. I was sure, and now I've got to question everything.
Yeah, sorry.
I don't know about myself. What are the Scorpio personalities? We'll make a decision now on whether star signs are legit or not. Off that.
Oh, I'm not really sure.
know?
People just tell me they're never good. They're never complimentary, which I don't really like.
Really?
Yeah.
I thought that the reason why people believe them is that they read their star sign and it's like, you are funny and cool and you love to have fun with your friends. And they're like, yeah, that's so me. And then they read the next one, it's like, you're da-da-da-da-da. It's like, oh, that's also me, but this is more me.
I think that's for all of them except Scorpio.
Cameron
Do you
Ware
have
Rob's coming
research?
on the mic.
Leos love to lead, perform, talk, be admired, and receive praise and
Literally.
respect from others.
Well done, Johnny.
I just need that I'm really struggling for words today.
They are
I need
naturally
that for-
regal and always assume a boss-like stance in any relationship or group-like dynamic.
Okay, maybe
I need
not.
that reinforcement. No, that's me. What are you, Campbell's a virgin? No, I mean Virgo? What's that one again?
This is already.
We'll rehash it.
Terrible, abrasive,
Yeah,
disrespectful.
That's a negative one, yeah. What's the Scorpio one? Do we work that out?
The coolest one.
Oh.
I'm also a Scorpio.
Oh, nice.
okay,
Okay.
okay.
Well, I think you might actually be a Libra. Sorry to tell you.
Identity crisis
Everything's
over
ruined.
here. That's first time camera boy Rob on the mic.
Yeah, we
That's,
got him a new mic so he can fact check us.
Speaking
good.
Speaking of new dimensions, that's a that's a fifth dimension there.
Well, thank you very much for your time today. We really appreciate it. And it was a really good episode. We really enjoyed all of these facts, like blowing my mind.
But I think it's like a general trend as well, like the whole idea of not challenging the norm. That sounds so like, cliche, but yeah, I don't know, working in a field where, things can constantly change and where like work is to disprove, past theories and stuff. I don't know if that can be brought into your actual life.
My mind
Except
was blowing like
conspiracy theories.
supernova cosmology.
Yeah.
Nice.
Yes.
Very good. You can tell you guys are professionals.
Yeah, exactly.
I take pride in
I
my
hope we
work.
held down the fort. I just went on some really weird tangents then, so sorry. But thank you, Dr.
No,
Georgie
thank you
Taylor.
very much.
very
This
much
was
for your
fun.
time.
Thanks, guys.